In this class, we are going to see about OR gate. OR gate will perform logical addition. That means adding of input signal. See the logic diagram and logic symbol for OR gate. This is the two input OR gate and the next one is N input OR gate. So here we may have A, B up to N number of inputs and only one output. Here we have two input. So we need to take all input whenever we are drawing to table. We need to consider all input and output combinations. We may have 4 input combination with 2 inputs because the number of combination is equal to n squared. N is equal to number of inputs. So we will draw the truth table. So first I need to draw the input names and output names. So here we will have the combinations like zero, 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 1, 1, 0, and 1, 1. So these are the 4 combinations for the 2 input OR gate. So now we are going to add this. So the first one is 0 plus 0 is equal to 0. And next one is 0, 1. So here for the first case, both A and B inputs are low. So the output must be a low. If at least one signal have high level, then we will get high level input. So you can get 1 as input. So here for the second case, B is having a 1 value. So this is representing a high level. So we will have a 1 as output. As same as the case 2, for the case 3 also, we have 1 for input A and 0 for input B. So we will get 1 as output. And here also, if at least one signal have high level, then we will get high. So here, both A and B signals are having high level value. So we will get 1 as the output. Then we will move to the timing diagram for the 2 input OR gate. If you want to draw any timing diagram to OR gate, definitely you need to consider about diagrammatic representation for each input and output variables. How many waveform will you get? So we will get totally 3 waveform. 2 for the input and another one for the output signal. So now we will mark each case as each timing phase. So the first case is T1. Following other cases are T2, T3, T4. So we will check the first phase for first or phase for A. So for A, in T1, A has 0 value. So we will draw 0 here and we will mark as 0. Then for the T2 phase, A has 0 value. Then for the T3 case, A will go to high. That means A will go to 1 value. And same as for the T4 value also, A will go to high value. So this is the timing diagram for input A. For the B, in T1, B has 0 value. In T2, B has 1. So then in T3, B has 0. So again low level. Then in T4 phase, B has 1. So high level. This is the timing diagram for B. So after that, we will add those things for the output Y. So here in T1 phase, output Y is 0. For all other following phase, Y have 1. So it's moved to high level until T4. Then we will mark as 0, 1, 1, 1. Okay. So this is the timing diagram for OR gate. That means 2 input OR gate. If OR gate is providing logical addition, how it provide logical addition? We are providing intelligence by using circuits. That means circuit contains resistor, diode, transistors. To provide logical addition, our 2 input OR gate inbuilt with this type of circuit. We are integrating this type of circuit to perform 2 input OR gate operation. It's having 2 diodes. So I am naming 2 diodes as D1 and D2. And these are input as order A and B. And Y is the output. Here we have a resistance called R and the resistance connected to ground. We are connecting cathode of these diodes to ground. Then we connect that output like this. Now we will come back to the operation of this OR gate is coming with this circuit or not. We will check that we are getting same output or not using this circuit. When this diode will be on means whenever anode voltage is higher than cathode voltage, then these diodes are going to on. That means short circuited. Otherwise, these diodes are going to be open circuited. So I am taking the combination. So first case, A is equal to 0, B is equal to 0. So we need to get 0 at the output. We will check it. Whenever you are providing 0 here, then how circuit is going to work? So you need to give higher voltage to this. Already you are connected to ground for this cathode through some resistors. That means you are applying 0 voltage to cathode. So you need to give higher voltage than 0 to on the diodes. But in this case, you are giving same voltage compared to ground. Then what will happen? Diode is going to off because anode voltage is lower than cathode voltage. So here both diodes are going to off. That means open circuited. So for the A and B, the diode is going to off. So we can cut the connection. So we will do the other parts of the circuit. So when you provide 0, 0 at inputs, these diodes will be like this, having open path, and the remaining connection will be like that. Output is directly connected to the ground through the resistance. So here we have a connection path from ground to output through resistance only. So the output is equal to 0 for the case 1. Then for the case 2, A is equal to 0 and B is equal to 1. In this case, we need to get logical addition, that means OR gate, output as 1. We will check it. For example, you are providing to terminal A as you are providing 0 to cathode also. This D1 going to be off condition. So we can cut the diode and we can cut the connection. That means open circuited. In the place of B, when you provide 1 as input, that means you are providing some higher voltage to anode. Then this diode will on. It will give you a short path. And the connection is like this. Now the output is connected to 1. So output is equal to 1. Then for the case 3, A1 is equal to 1, B1 is equal to 0. As same as the case 2, we will change the order of the connection. So here we need to cut the connection for B. Then we provide 1 for A. So here in the place of A, when you provide 1 as input, that means you are providing some high voltage to the anode, then this diode will on. That means the D1 diode will on and it will give you a short path. then the connection is like this. Now the output is connected to A. That means the output is equal to 1. Then for the case 4, both diodes are in on condition because the both A and B values are equal to 1. So we provide higher value to both A and B input. So having higher voltage than cathode. So after that we are having 1 as output. So we can finalize that this is the internal circuit for 2 input OR gate. So like this way, we are integrate all circuits to behave like logic gates. Thank you.